P critical. What was it? Our P critical that we calculated is equal to I forgot. So our P critical is equal to 37.849 times 10 to the power 3. 37.849. So 37.849 times 10 to the power 3. And then we have an area. So the area is pi r squared. Okay, pi divided by 0.025 squared. Okay, so 37.849 power 3 divided by shift pi divided by 0.025 squared is equal to 19.276 times 10 to the power 6 Pascal, which is less than the stress yield of what? So the U that's given to us is what? 703 times 10 to the power 6 Pascal. Okay. So this is where your, okay, this is again equal to mark. Okay, this is again 1 mark over here. Okay. So what if now, again, I want you to be comfortable. Let's say you put in the wrong value, your stress critical. So you use the other number that you have, which is 30.842 times 10 to the power 6, 30.842 divided by pi 0.025 squared. Okay, so you get 30.842 power 6 divided by shift pi divided by 0.025 squared is equal to 15.708 times 10 to the power 6 Pascal, which is greater than your stress yield of what? 703 times 10 to the power 6 Pascal. If you have written this out, you get 1 mark. Okay. If you have written this, which is not true, okay, this one you will get what? 0.5 marks. Pretty clear. Okay, so this is what we mean by grading by steps. Okay. Does that make sense to you all or no? Or this is different? Other courses you are not marked this way. Any feedback?
Do we always have to make a check, or just when
Always,
it's
you
asked
have
for?
to. You always have to make a check. Okay. So this is where, don't worry, I will post this summary sheet. You all can, I mean, after this, as usual, I'll upload all my notes. Okay, so this will be down there. Okay, so I hope from here on, I really forget, thanks to Felicity, she reminded me. I really forget how I wish I've done this earlier with you guys. Okay, but this is the way you write your summary sheet, and it's not just this subject, all your subjects, right? So I'll give you an example now. So once you start improving your summary sheet, this is all you need to study for your what? For your term test, rather than going to week 1 notes, week 2 notes, week 3 notes, week 4 notes. You just need to read this and you're good to go. You get what I mean? So it helps you prepare for term tests and final exam much more easily. And you're not worried about the scheduling. If people give you back-to-back final exam, you say, I'm fine. I have summary sheet that's good enough for me to study. Okay. And this is how you become successful in university education. Likewise, this is how you become successful in when you go to industry. And I have students telling me, Eugene, isn't your notes a summary sheet? What do you think? After what I've written today, what do you think? It's not, right? A summary sheet is it's something very summarized, a condensed, like half a page like that, or sometimes can be 1 page for 1 week of notes. Okay, right. I don't want to keep on preaching this. Okay, any question before we can do like a revision, a short revision for eccentric buckling? Anyone, please? Oh, someone has a message on chat which I
Can I go back to the previous page? You just wrote things.
this one.
No, the equation with the equation you wrote in yellow. Yeah, this one. Why the first line we can get 1 mark, but the second line we only get half of it?
Sorry, this is 10 to the power 9.
Oh, okay, that makes sense.
Okay, so that's why the first one is 1, the second one is half. Okay. Okay, so I don't hear anyone having any question in any other questions before we go on? Okay, I don't hear anything, but there are some questions I think I did in the homework or doing the example. I think this is a very important point. Okay, buckling will tend to more likely occur when for the lower I, which is second moment of area. So we all need to check. Okay, we don't have the opportunity over here, but this is one of the things that you put in when you're doing more examples. Okay, right. So the next topic or subtopic that we are going to look at.
So I have a question about homework too.
Yes. Question
So,
number.
Question number 5. After we calculated Ix and Iy, I saw a formula we didn't use in the lesson.
I'm not going to follow what you see. I'm just going to teach you what okay. That's the problem with the solution manual. There are things that's done that you don't know why. But if you were to follow the technique that I teach, you don't need to worry about it. So I will do question number 5. What do you think? Okay?
Sounds good.
Okay. So today the class will go probably a bit longer. Okay. So but not necessarily longer. Let's look at this. So let's look at eccentric buckling. Right. Let's look at eccentric buckling analysis or eccentric buckling. Okay. So eccentric buckling, there are 2 formulas. Okay, so there are 2 formulas that are critical. Okay, so I've written for you, or based on the formula sheet, we have Y max is equal to E, and then we have secant pi over 2 square root of P over PCR, and then we have minus 1. And then so you see a formula like that, and you know that inside the secant over here, this is in what? Radians. Can someone tell me why is it in radians and not in degrees? Why is the secant inside here you have to calculate?
Because the pi over 2.
Yes, okay. And throughout my years of teaching, I have so many times this is so fundamental. Okay, Felicity, well done. Okay, so many times students just did not know how to change the calculator from degrees to radians, and even at a stage where student asked me, have I started recording? Student asking me, Eugene, what is a radian? Oh, for crying out loud! But anyway, that is history. Okay. So you see down here, right? We have formulas. So likewise, PCR is equal to pi squared EI over what? Over L squared. Okay. And then E, so one thing is not sure over here. So P is known as the applied load. Right? Then we have E. E is our so E, basically E, if you can't putting words is pointless. So what you do is E, right? You just need to draw this, and then you come over here. This is your centroid, right? And you just, okay, so this is your centroid. And then you, under eccentric loading, this is your P, and then the distance from here to here, this is your E, right? So this is how you define your E, yes or no? And then the next thing that you write, okay, I know all this now. Then the next formula that we need to know is stress max, right, is equal to P over A, bracket 1 plus by EC over R squared multiplied by secant. Okay, then we have pi over 2 square root P over PCR. Okay, so these are the two key formulas. The rest of the formulas you can still adapt, like PCR is pi squared ER, and the rules still apply. Okay, the rules still apply. So this is just a subtopic, okay, which is eccentric. Okay, so now from here, again, I don't know what more to add. Okay, I just understand this topic. Yeah, this is very, oh, the next thing is C is the distance, is the furthest distance between the centroid and the structure. Okay, that's all you need to write. Okay, and you do the what? You do the blah. I'm running. You do the summary sheet based on what you understand. Okay, does not need to be perfect. Okay, so next I want to do question 5. Okay, again, anything we learn new, we update over here. Okay, anything we learn new, we update over here. So we are going to do question number 5. Yeah, hold on. We are going to do question number. Looking for my file with question number 5. Apparently, question number 5, I just read the question. The question is based on centric loading. Okay, but anyway, I will do question number 5. It's a tricky question. It can be. Okay, so this is homework 2. And question number 5. Okay, a compression member, 9 meters. So we have L equal to 9 meters. And it's welded 10 millimeters. So this is 10. This is 10 millimeters thickness. Okay, given those thickness are 10 millimeters. And there's a plate of W250 by 80. Okay, so we are given that